Building apps using Kotlin Native, Pragmatic introduction overview. Who am I? Hey, I'm Jeremy. I work at Etsy on the buy and sell apps. I've been investigating multi-platform Android technology as a hobby the last 4 years. Prior, I was doing back-end development in Java, Python, JavaScript. I've been looking at React Native, Flutter, Kotlin Native as a hobby. I have some weird hobbies. Etsy is investigating Kotlin Native, Flutter, and J2 Objective-C. I'm an Android developer learning iOS, so not to build complete apps, but to try to bridge the app and understand more about the various technologies. As I said, I work for Etsy. I don't represent JetBrains, TouchLab, or anybody else. I'm just somebody trying to investigate the technology, understand it, and build apps for real people. This is my first droidCon, so I'm gonna have to imagine everybody with funny sombrero hats. So here's some of the learnings I've been doing the last year on my GitHub. I think the more code I write, the more you can understand about the technology. These are some of the open source projects I've been working on. This is called Git Notes. It's kind of like Evernote or OneNote, but I want to use Git because I want to take control of my notes. I want to version control them. I want them on my desktop. I want them on mobile. I want to be able to control my notes. So this is one app I've been working on. Another app I've been working on using Kotlin Native is called Java, yet another background app. Connect to the Usplash server, and I want to be able to download images and put them as background on my iPhone, Android. You can see I have the Android and iOS app going. So what is this talk? Why? Introduction. We're going to build a basic application together. We'll do the comparison to other competing technologies such as Flutter. We'll do a current state. We're not going to do a deep dive. There's some really great talks coming up today and tomorrow where some of the presenters will explore in a deeper dive some of these topics. So, moving on. Why? Why do we care? Why do we want cross-platform technology? Let's look at the status quo. What do we have today? We have two code bases, which at many organizations means two teams. iOS and Android are very unique, very different. They have their own strengths and weaknesses, but we're duplicating a lot of logic. Do not repeat ourselves. We have two teams that are working independently on similar problems. There's no common language or architecture. It's difficult for the Android and the iOS teams to communicate with one another. This is resulting in accidental differences, which I consider tech debt. Sometimes the applications are built concurrently, and sometimes they're built a year apart. Sometimes people build an iOS app, and then they'll build an Android app a year later, and they diverge quite a bit. The accidental differences are making it harder to maintain these applications and update the applications. When they don't work the same, it's difficult to execute experiments, it's difficult to maintain them, it's difficult to go back to my stakeholders and say, this is how long it's going to take to add a new screen or update the screen if they're built completely different. These are accidental differences. There's also intentional differences where I want to reuse the platform-specific differences to my benefit. Cross-platform, we're spending too much time on boilerplate and architecture. When I build an Android application, I'm spending a lot of time just messing around with JSON, the networking, the business logic, the unit tests, all these things that have no value to the user. I think we're spending too much time on this. Cross-platform is the history of computing. This goes back to the C language and the early 70s. And I go back to how I started. I was on the building websites for Netscape and IE. And I had to build the website twice. And we had these powered by Netscape, powered by AE I think the cross-platform convergence is just the history of computing, and I think the mobile is still young, so we still have room to try to consolidate these together. Android developers are from Mars, iOS developers from Venus. No, not literally, but we're so similar yet so different. One is 100 degrees below zero, the other is 450 degrees. We're partners, not competitors. We're both equals in different markets. The iOS dominates the domestic market, Android the international. We have similar backgrounds, but we don't have a common language. We can't talk to each other well, and it's preventing us from working together and sharing. So code sharing is a solution. Figure out which problem you have to solve. I think as far as code sharing and these cross-platform technologies, the technology is just one facet of the entire ecosystem. I think the culture, the team dynamics, the architecture, the experiences are much more important for large adoptions rather than just cranking in a technology that may not be feasible. You have to look at your team, your app, and your existing code base. It doesn't make sense for everybody, as I said. Avoid HDD and whataboutisms. HDD is my term for headline-driven development or hype-driven development. And whataboutisms, like everybody's like, what about Airbnb? What about Dropbox? What about this? What about that? It's great, to look at these case studies, and think about what went wrong, what went right, but you really have to dig into the details and really read through the full details. Like Airbnb was like an 8-part article. They did a lot of interviews, and it was very nuanced. Some of the decisions they made and some of their conclusions. Each team, each app is different. You really have to think about if it's a good fit for you. It might not be. Here's my hype-driven development. Writing code once, running on multiple platforms is a superpower. I believe in the future of multi-platform development. So, next step, what do we do now? What do we do now? So, I think the first step, before we can even look at the technology and starting to write code that runs on multiple platforms, is we need to find the common ground and the shared problems between the Android and the iOS. And that's going to be very unique to your app, your organization, and your team. I don't know what you're building. I know what I'm building. I know my problems. We need to understand each platform. We can't just silo ourselves, say I only understand Android or I only understand iOS. That's not going to get us closer together. So I think as Android developers, we need to understand the basics of Swift, view controllers, ARC, automatic reference counting, Xcode storyboards. And the iOS developers need to understand Kotlin, Android Studio, garbage collection, activities fragments. We don't need proficiency in both of them, but we need to understand the nuances, the trade-offs of these different platforms if we're going to move closer together and find common architecture and common problems. Just deploying one platform to the other platform is going to result in pain. All of these different patterns that we talk across the different platforms, they're a lot more similar than different. They're solving very similar problems. I think that we can, per app, we can come to common architecture, we can figure out common abstractions, common patterns through our understanding and the nuances of each platform. And from there, we can figure out what and how we want to share our code. In a perfect world, the iOS and Android engineers should be able to get in a room, discuss common architecture, discuss the trade-offs of each platform, review each other's PRs, and have intelligent conversations about the different barriers. We can't share code until we start break down barriers. We can't just take some code, compile it, deploy it to iOS, and expect everything to work out great. Maybe you can, but it doesn't work for my apps and stuff I work on. So I love multi-platform. So, and I've been working on this for a long time. So, and I've thought about this deeply. Here's my wish list of what I want to see out of a solution. Empower teams to choose the best technology. I don't want to do a big risky rewrite. I don't want to disrupt my users, for a long period of time while I'm rewriting the app. The rewrites are always harder than you think. There was a lot of micro decisions that went into all of these different applications over time, and these accidental differences are now baked into your application. The users expect them, and when I make changes to the application, it's disruptive to the user. Integration with the underlying platform should be the default, not the exception. I think the integration is critical, reusing the nuances of the iOS and Android platform and leaning into them rather than just trying to hide them and wallpaper over them, isn't going to be better. I want to decide what and when to share. Google and Apple are innovating. They're releasing new APIs, frameworks like dark mode, the background restrictions, the sign-in, the gestures, the Swift UI, the compose, and it's speeding up. I need to be able to use all of these technologies on demand when I want to for my application. I don't want to force decisions onto the developers or tell them what they can and cannot do. I want to be able to empower the developers to use the technologies they want per team, per module, per feature. Another thing that I've struggled with is the learning curve. I want to reuse one of the supported languages, Kotlin Swift. I don't want to learn a whole new language, a whole new paradigm, different tools, different SDKs to be able to build an application. If I have existing team of developers that spent years understanding Android, iOS, taking them, doing a 180 and learning a completely different language, a completely different toolkit, different compilers, different IDEs, different nuances, it's going to slow down and disrupt the team, not empower and speed them up. That's what I want out of a multi-platform solution. I think this is what we forget sometimes. When we're discussing all these technical problems, people don't want to use your software. We need to make better software, and we need to remember the users. We all love to solve hard technical problems and geeking on the latest cool tech. I do. I love discussing MV architectures, coroutines, code sharing solutions, but it's about the users and giving the users a better experience. What do users care about? They care about dark mode, sign-in, gestures, battery life, network optimization, the features, the performance, the offline support. They don't care about which underlying libraries used. They don't care whether they use Moshi or JSON, or they just want something that works. So here's a quick story. So prior to Etsy, I used to develop mobile apps for enterprises, governments, oil, airports, universities, etc. So the benefit of this is I got to engage with a lot of real users, end users, the managers, and our primary competitor was a web-based application using Cordova. And I used to try to talk to these users and try to explain to them, our app is way better, it's native. Company B's app is web-based, it totally sucks. And I would talk to them and their eyes would just gloss over. They didn't understand. They're like, what does this mean? They're like, I just need something that scans barcodes or tracks my inventory or does feature X, Y, Z or works offline. They didn't understand, they didn't care. Again, the users don't care about the technology that powers our application. They care about the experience it enables them to have. And I think this is important to remember whenever we're discussing any kind of different technologies. What is Kotlin Native? Let's jump into it. I talk a lot about what I want and why I believe in multi-platform, and I'm going to talk about why I think Kotlin Native is the best solution to meet my needs. So we already have the ability to share code, Kotlin code on the back end and the front end using the JVM. We can already compile Kotlin Native for JavaScript. Kotlin Native is a compiler toolchain. The backend uses LLVM. It enables us to compile to different targets where virtual machines are not available, such as iOS. When we compile to iOS, we're compiling to a binary framework file, which can be imported into the project and accessed as Objective-C library. So opposed to some of these other solutions, like React Native, there's a single dependency, the Kotlin standard library. We're not pulling in, dozens of dependencies. I don't know where they came from that cause problems, throughout my applications. We're integrating with the iOS memory management system. We're using automatic reference counting, and there's a GC in there to cover the cycles. Cycles can occur with circular reference, such as a view presenter that link to each other or a circular linked list. When you're using Swift, they have facilities to deal with this through the weak references, but Java does not. But the majority of the code will use the automatic reference counting. So, I talk a lot about interop, choosing what to share, when to share. I think this is the single most important feature of a multi-platform technology is the interoperability of the platform. And it's not just the interop with the native SDKs, it's the interop with the code I've written, the code that I've spent years building that works the way I want. It works the way I want because it's in production and it's working for the users and the business. So Kotlin Natives provide us an Objective-C binary with a header file. So as far as the iOS app is concerned, this is a Objective-C library. Uses a CocoaPod integration. So there's a Gradle plugin that will create and export a CocoaPod file, and when the Xcode project is built, it will compile the appropriate Gradle task and take care of the framework file. This is pretty awesome. The common Kotlin code can access all the iOS platform APIs, Foundation and UIKit. This means the Kotlin code can access the Kotlin standard library, and in the iOS module, I can also access the iOS specific libraries. This comes down to the interoperability. I'm going to dive into this a little bit more. I think this is super critical, as I can use all my existing abstractions. Classes to interface with Lambdas exceptions. I can create data classes. I can pass them across. Some of the other solutions that I've looked at and experimented with, I have to build a bridge layer. I can only pass primitives. I have to manually marshal everything back together. It just introduces a lot of friction into there, and whenever I need to interop with the native platform, I want to use notification, background services, existing code. It's just complex, and I can't use the same MV patterns I want to use. And I think that's like some of the trouble that, if we're going to talk about like Airbnb, I think that's some of the trouble they had. I think that's some of the trouble Dropbox had. It's the interop layer and the interface just wasn't as friction-free as they needed it to be. Kotlin Native is a library, not a framework. So compared to some of the other solutions like Flutter, React Native, it's completely different, for better or worse. We're going to do a comparison a bit later. As I said, choose for yourself. So tradition demands we start with the Hello World example. We use the Kotlin compiler, compile Hello World KT. I use the Java, run it, outputs Hello World. I run the file. It's a Java bytecode class. Great. Nothing too crazy here. Kotlin Native, we have the same thing. Hello World. The only difference is now I'm using the Kotlin C-native compiler on the same code. And now I'm able to execute the Hello World directly without using a JVM, which is pretty awesome. I run the file on it. Yes, it's a 64-bit executable on my MacBook. So, what does it look like to compile for as an iOS library? Same thing, Hello World. Now I'm going to use the Gradle command. going to build. I check the file, 64-bit dynamic link shared library. Cool. I check the file's header, Objective-C source code. So this is a framework file important to iOS, and this is just a native compiler. And so I think the moral of the story with all this is just removing some of the magic. It's just a compiler technology. We're taking Kotlin code and we're just recompiling it for a different target. Nothing more, nothing less. So, is this some Gradle magic of an iOS app for free? Not exactly. Let's dive deeper into that. So, I have a shared common module, which is the green entry. The iOS framework has access to the iOS framework module, and then there's an Android-specific framework in the blue. They both depend on the green Kotlin common module. The iOS framework has access to the Objective-C libraries like the Foundation and the UI kit. The common module can only import multi-platform available libraries from Kotlin. So I can't import Java libraries into the common. I can't import Room, RxJava, Glide, all the fun things that I use today and I love. But the Android app that will reuse the common module, this is where I can put Glide, Room, RxJava, all the other Java libraries into here. So the Android app will import the common module will import the libraries. The Gradle metadata feature added in 5-point-something enables us to reference the multi-platform libraries, which will pull the appropriate architecture during the compile phase. Android libraries. The iOS application will be just a straight Xcode application. I have a dependency on the common module, and there I can import all of the Swift and Objective-C libraries that we all know and love. Not me particularly, because I'm not an iOS developer. But so, what does it look like in IntelliJ? So in this photo, the lib is a multi-platform enabled module. I can have more than one, but for my example, I just did one. So there's 6 directories for the common, the iOS, and the main is just the Android. Each one has a corresponding unit test directory. We're going to dive into this a bit later, but I think the testing and the ability to develop common tests and platform-specific tests is a killer feature. So just to reiterate, 3 main Kotlin modules. The Kotlin code, which has the limitations. There's the iOS code, which is deployed to iOS, Objective-C Swift libraries, and Android code deployed there. This is all written in Kotlin. So at this point, if you're following along, I'm thinking the common module isn't very useful. If all I can use is Kotlin standard library and Kotlin code, it's a one-way dependency. I could pull that into there. Like, what can I actually do? I can do an add function, fun add, int, return int. Great. I can do maybe some collection stuff. That's not super useful. Fortunately, it gets a lot better. So, bridging the gap. So I keep talking about the integration capabilities, and lowering the barriers for the friction. Let's explore what that means. Common code using Kotlin standard library is not useful enough on its own. Maybe it is for your app, not for the stuff I work on. So Kotlin Native introduces 2 new keyword abstractions, expect and actual. Expect provides the headers of the function or class. It's similar to how an interface works, and actual provides the specific implementation per platform. Actual is similar in concept to the override keyword. Actual provide they fulfill the platform-specific APIs. The difference between this and an interface is when I define expect, that means I need exactly one implementation per platform. So when I say I expect a log message string. That means I need to define exactly one implementation in iOS, Android. If I define another target, such as JavaScript, I would need to define exactly one other. And then using this, opposed to an interface, it doesn't specify a particular data type. This abstraction is extremely powerful, and we can use it to wrap essentially any API we want. And I'd be able to access the full capabilities of the platform. Dates, arithmetic, background services, notification, data access. We could also, in theory, define a abstraction for a common UI, though I think UIs in particular are better left to the Swift and Kotlin. There's nothing in the platform that prevents you from doing that or anything else. So, example. There's no multi-platform logging yet for Timber. Jake Warden says soon. Let's build our own. So, simple requirements. We want to be able to accept a log level, debug info, error fatal, string, and an optional exception. I want to be able to use the Android logger, and I want to be able to use nslog, and I want to be able to access this through a common abstraction. So we create a sealed class, debug info, warn error, and I just create two methods, one with a throwable, one without the throwable. So I just overload it, and as I can see in IntelliJ, the A provides a shortcut that enables me to jump to the platform-specific implementation or allows me to create it if required. So what does the iOS implementation look like? Import platform foundation nslog. This is Kotlin code. I think this is amazing. I'm writing Kotlin code and I'm importing from the Objective-C libraries, and I'm able to implement using nslog in the Kotlin code and define a common abstraction that I'm able to use on my common libraries. This abstraction can be extended to wrap any of the platform APIs we want. And this is how a lot of the multi-platform libraries are implemented. As of Kotlin 1350 release Thursday, JetBrains is saying that all libraries from iOS are available in this abstraction. The Android should be fairly simple. We're going to use the Android logger, or we're just going to implement the two implementations. It's pretty awesome. So far we've been looking at some trivial examples, a lot of theory. Let's look at what building an entire application in Kotlin Native might look like. We're going to use the MVP architecture, not an endorsement. It's just easy to grok. So what do we have? We have an Android app, an iOS app. My Android app has the view layer, the fragment. iOS app uses the UI view controller. Then I have a common set of code. I have a presenter layer, which I'll develop in Kotlin code. Interactor, where I can put my business logic, and further level logic to deal with repositories. I can develop a repository layer for my persistence, SQLite, shared preferences, repository for the networking, HTTP, serialization, JSON. Square is also released, Wire 3.0, multi-platform proto-buffers. I haven't played with it, but it looks awesome. Dependency injection. We can do common dependency injection, but I'll get into this a bit later. I think dependency injection is best left to the platform because I'm going to have to pull in dependencies from the platform, combine them with common dependencies into a common object graph. But these are just personal opinions, and there's nothing. And then on the iOS side, we're going to use a custom dependency injection because I don't know that much about iOS to develop it. But the iOS conference people have some stronger opinions. Again, the platform, the library does not imply or recommend any of these solutions. These are just things that we're experimenting with. So let's look at the repository layer. What do I want to do? I want to be able to serialize JSON from an endpoint. It's pretty basic requirement. So Unfortunately, we don't have Moshi available in the multi-platform library, but we have something very similar. It's called Kotlin serialization. It's a first-party JetBrains library. JSON, CBOR, protobuf out of the box. The annotations are based on Kotlin data classes. It's conceptually very similar to Moshi. We apply the plugin. So the Kotlin serialization consists of a compiler plugin that generates visitor code for the classes and a runtime library that uses generated code to serialize objects without reflection. Kotlin Native, as it's deployed to the JavaScript and iOS platform, there's no reflection, which is probably a good thing. It's usable, but it's currently in beta. There's currently some missing features, such as lack of streaming parsing, but it may not be a problem for smaller payloads. So what does it look like? Data class greeting. Pretty simple. So we can take this data class, we just annotate it with the serializable annotation. In this example, the val name string will be defaulted to match the JSON value called name. We can override this, of course, if you using like underscores or don't want to match. Given a JSON input, we can easily just use the JSON parse API to marshal it back into the data class. The .serializer method is added automatically to all classes that implement the serializable. So it's just a single method that comes back. It's pretty simple. Next thing we need in our application is a repository. I want to be able to connect to a HTTP server, access some data, send it to the JSON parser. Cool. So KTOR wraps OKHTTP, OKIO, or HTTP URL connection. The iOS engine is provided by the async NSURL session, which is pretty great. So we're taking the existing libraries, we're wrapping them up, and just reusing them. Add some Gradle to there, the client core, and the JSON. The JSON will add a handler that enables us to hook into the first-party Kotlin X serialization. So creating a new KTOR client is pretty basic. I'm using the Lambda syntax. I'll show it a bit. This just gives us basic functionality that we all know and love. Get, post, put, patch, etc. It's an HTTP client. The next thing we're going to do is we're going to install the JSON parser. So we're using the greeting serializer we defined before, and we're just using the JSON annotation to install there. And what this means is that I can connect to REST endpoints, take the JSON, and automatically serialize it back using this serializer. It's pretty similar to retrofit and Moshi. Let's start building up the repository layer now. So suspend fun get greeting is just a suspension function used by coroutines, returns the data class that I built. So in this example, we're using client, which is the HTTP KTOR client I just created. We're wrapping in a lambda, the get lambda. And we're just taking the URL and we're using the URL lambda to compose my server/greeting. So my server is just the server name, and path is just the path. We wrap it all up into the suspend function. We can call from a coroutine. So whenever I think about repository or any of this stuff, my mind always jumps to like, okay, how do you test this? Testing is important for all of us. I hope so. So how do we test a repository? So the KTOR client gives us the ability to use what we call mock engine. So given the mock response, create a client, and this time I'm going to send in a mock engine. I add in my JSON serialization plugin from before, and then we set up the engine, and I set up the mock handler, the mock response, the HTTP status code of OK, and the headers. I wrap it into a coroutine, a blocking coroutine. I'm adding in the service. I'll get to that in a second. Actual response, expected response, and I just do a basic assertion, wrap it in a test annotation, and now I have repository tests using the KTOR. So to complete the repository out, I'm just going to wrap it into a interface with the suspend function. This will enable further testing mocking scenarios for other layers of the application. Greeting service. This will be the implementation of my API. There's two dependencies that we're receiving in here. There's an HTTP client and the endpoint. An endpoint is just the API endpoint. And we're going to implement the greeting API interface. So get greeting, we're just going to do the same client get we had before. We're just rewrapping it into a repository that we can reuse across more scenarios. So I'm going to just loop back to testing. I think testing is very important. I can't build an app without the ability to test. I think this is important. So I spent a lot of my time, and a lot of the code I write is just test code. And I think that's one of the code that we end up writing across Android and iOS. And this is a lot of the boilerplate. And so whenever I write boilerplate, I have to write test code to test the boilerplate. Code deployed to the common test platform will be compiled to each platform and executed twice on each unique platform. And this is important because it will take into account the expect actual. So it'll roll in all of the dependencies from the platform, take the same test code, and execute the same test code twice, which is pretty awesome. This enables us to reuse our existing tooling, CI infrastructure, and knowledge that we've obtained over the years. It's not perfect. The IDE support for unit testing is still incomplete. It's annoying, but it's not a deal breaker. You can run the tests from the command line. You can run individual tests using the --test parameter to run a single test, and I can use the print line to do debugging. The other issue, there's no mock-K support. I love mock-K. I use mock-K. Sometimes it can get overused, and developing your own mocks and stubs is generally not a bad idea. The original developer, I think, is in the best position to develop these. There's definitely interest and talk of porting mock-K to multi-platform, but there's some technical challenges related to that. Kevin Galligan will have some more detail if you're interested in mock-K support. So moving on to my MVP implementation, let's define a contract for the view. So this is just an interface which will be implemented by the native platform. So on Android, it's going to be a fragment. On iOS, it'll be a UI view controller. And this is an interface, which I think is pretty awesome. So there's two fields. Is updating, it's a Boolean. I'm going to get into that in a second. I'm going to use a Kotlin delegate observable to do callbacks in there. On update, it's just a reactive callback. When the data is retrieved, send it to the on update, and the UI will update it. So now we have the actions, which is my presenter. All this does is just fire off a request saying get the data. When it's completed, it'll do the on update. So on request data can move in at whatever. It could be a button, it could be a lifecycle callback, when the screen loads, whatever. So if we get into the presenter implementation, we have greeting presenter. We receive the UI context use case, which is my interactor, and my view. And my view will be the fragment or UI view controller. We get into the implementation. All I'm doing is saying on request data. Again, this can be a button. This can be a lifecycle event like on loading. I'm just saying view on updating true. The view will show a spinner. I'm going to go get the data from the interactor, send it back to the callback, tell the view to stop updating, and the view will handle the updates correctly. This is all common code that can be deployed on both platforms. So using the interface, I'm able to abstract away different things. So in the common code, as the view, the greetings view, I'm able to actually interact with the native platform, the UI view controller, or the fragment, and talk back and forth. So we get into the interactor. There's two dependencies in here. There's the API, which is the HTTP repository, and then there's the database queries, which is based on SQLite. So this is a pretty basic example. We're going to hit the database, check the cache. Otherwise, we're going to get it from the remote. We're going to throw in some business logic, trim it, uppercase it, update the database, return the result, whatever. Again, we can put this all into the common code for XT unit tests. So SQLite persistence. Broom is not available on multi-platform. Neither is core data. If you want them, you can wrap them into an API and reuse them. But I think we have something better. SQL geeks rejoice. I love SQL. So I love SQLite. So essentially, what it's doing is we're taking raw SQL as I would write it and creating the table. I'm running two queries, insert or replace and select. And I'm able to take the raw SQL, and the SQLite plugin will generate my repository layer for me. So I think opposed to like the ORM and the other solutions like core data, where they try to hide away the SQL from you and try to develop this common abstraction, SQLite fully unlocks the power of SQL and allows me to fully utilize every single feature of SQLite, which I think is pretty awesome because I love SQL. And I've done a lot of like complex joins and different types of abstractions. So next we get into the iOS integration. So as noted earlier, we take the Gradle, we compile it into a framework file, which is imported into the iOS. So it's using a pod file. So there's a Gradle task called generate pod file, which will generate this file, take it into the iOS project pod install. When the Xcode project is built, it'll trigger the appropriate Gradle commands to build and compile the Android app. So if we look into the Xcode project, development pods, lib framework is my multi-platform library, and also generated the headers libh. So as far as Xcode's considered, this is Objective-C library, and that's how we're able to access all the abstractions. So we're going to dive next into iOS. I'm not an iOS developer, but this is my best. So import lib. Lib is the multi-platform library that I developed. UI view controller is the Swift code. So in here, view unload. This is awesome. So let greeting equals greeting, hello droidCon. This is the Kotlin Native data class I built earlier. So as far as the Swift code is concerned, this doesn't look foreign or abstract. This is just pure Swift code. It looks like a Swift class. Swift always defines the properties like the name. That's just how it is. There's no magic. There's no ceremony. There's no asynchronous bridges, screwing around. It's about like reducing the friction and lowering the barriers. So dependency injection. I just spun up my own dependency injection framework for iOS purposes. HTTP client, get the service. If you have a different dependency injection framework on iOS, use it. There's nothing stopping you. So I'm running out of time. I have to move a little quicker. So the presenter greetings view is the interface I defined earlier. We're just implementing it, greetings presenter, and then the view, I'm just passing an instance of itself to the presenter. So when the presenter interacts with it, it's looking at the greetings view, which is an interface, which is actually the UI view controller. In here, presenter on request data, I'm able to load the data, send update. Coroutines are single-threaded, dagger, sorry. Android implementation, we all know Android. Okay, concurrency. The story is still evolving around concurrency. Simple in concept, difficult in practice, but it's not that hard. It's not compatible with existing JVM-based coroutines. Bridging the two worlds is challenging, and when things go wrong, they result in runtime errors, which kind of sucks. But and there's some issues, like the KTOR client can access the main thread. This doesn't mean you can't use it on multi-platform, but there's just a little bit of ceremony until they can fix it in 1.3. Ben Asher is giving a presentation tomorrow about his library coroutine worker, and there's also reactive with a K, which is like RX Java-ish. So, how do we? What does concurrency and multi-platform look like? Meet the worker. Workers are primitives built on top of threads. Two basic rules. All mutable state is owned by one thread. All shared state is mutable frozen. Fine, it's pretty basic. Immutable data can be shared across threads safely, only available in the native module. This can be a bit tricky, the concept of immutability. Kotlin language does not have language level immutability yet, but they introduced a abstraction called the freeze. You have to be very careful with the freeze, particularly with lambdas, as it can capture the outer scope and freeze the UI. And we need to be able to work around these abstractions because we need to be able to interact between the background and the UI code. This is the freeze method. It's available on all objects, and this provides everything immutable. So let me just do a quick example. So I'm running out of time. Worker start, worker execute, transfer mode safe. This should be the default. So there's the producer lambda. So when I want to send data to the background thread, I need to call the freeze method before it sends in the producer. This is the background process. So it will have access to only the data sent in from the producer. And then from here, I can mutate the data, create copies of the data, and return it. So in here, I'm going to take hello droidCon, freeze it, uppercase it, send it back. I could do a future, consume the result from there, and output the data. And it prints as expected. So just to show you how you can get into trouble, particularly with these runtime exceptions, it's the same example, fail well. Everybody remembers fail well. So hello droidCon freeze. This will explode in production. It's going to explode because of my input. My input is captured from outside of the producer scope. So again, this will fail at runtime, which is kind of sucky. And you'll get an error like this. Work execute must get unbounded, non-capturing functional lambda. Lame. Okay, so we can bend the rules, but we can't break the rules. Meet atomic reference. So I can take an atomic reference. I can package in a data class. It's frozen already. The value's frozen. I can pass it safely into my worker. This is crazy. Create a new greeting class, and I can mutate the value in the atomic reference with the value and assert the value. So there's ways around it. You need to be careful with atomic reference. There is performance implications. There's certain use cases like global service objects, database connections, where we need to use these abstraction. Quickly, there's one more way around it, detached object graph, where we're just taking pointers, we're sending it into the asynchronous code, we're attaching it to there, and we're able to actually mutate the object. We're verifying that it's actually, when we detach it, we're detaching it, we're passing the pointer, and we're attaching it inside of a different thread. When the thread ends, the reference count is released, and we're able to attach it to another thread on the return and actually do mutations. I think we need to be careful with some of these abstractions as we can get ourselves into some hot water. The community is still trying to work out some of the best practices, libraries, architecture, but these are the core building blocks to build more complex systems. I think most people's experience with Kotlin Native will be through some of the third-party libraries that the community is coming up with. So Kotlin Native is not all rainbows and unicorns. There's elves also. Everything has trade-offs. Multi-platform development is still hard. Developing an app for multiple platforms will always be harder than developing for a single platform. I haven't found anything anywhere that will make this easier. There's just more surface area, there's more complexity. No matter what, we require knowledge of Android, iOS, and the multi-platform technology. Multi-platform solves some problems, introduces new problems like concurrency. We're still figuring out the architecture and the best practices. But just because things are hard doesn't mean we shouldn't try or we shouldn't do it. Kotlin Native is the future. I believe it's the future. Is the future now? It's still in the early adopter phase. There's still some rough edges. I guess tell me to wrap it up. Okay. Here's what we're all here for. Kotlin versus Flutter. Kotlin is compiler technology, native SDKs. Flutter is an alternative framework. It replaces the entire SDK. Flutter maximizes code sharing. Kotlin Native get you more places. Flutter, it might get you there faster. My limited experience with Flutter, integration into a brownfield app is not good. There was a lot of problems. I'm still working out the issues. I'm talking to Google. We're trying to figure them out. Then you end up with the shared UI and the uncanny valley. I think in a greenfield app, it's good. Grow to adoption, start small, avoid big stages, prototype experiment. Discuss with your team, be aware of limitations. And that's it. Thanks for listening. I hope you learned something. Feel free to contact me with any questions or this guy.